Okay, hi everyone. Let's get started. My name is Richard, and today we'll be continuing to talk about Python lists. So before we start with the new information, let's do a quick review. So over here, I have some practice problems to help us review what lists are and some of their basic operations. So let's start from the fundamentals. Which of the following is true about lists? A, lists can only have one data type. B, lists are mutable, meaning items can be added, changed, or removed. C, there cannot be duplicate items in a list. And D, lists are not ordered. So, um, have a moment to think about it, and if you know the answer, you can feel free to unmute and explain your thinking and reasoning. Yeah, and you can also type in the chat. Okay, does anyone else have anything to say? Okay, so Michael said B and D are true about lists. So D is actually not true. Lists are ordered, and that's a very important aspect of lists. Um, so for this question, only B would be true. A is not true because lists can have multiple data types. C and D are also not true. We can have duplicate items, which is not the case for tuples, which we'll get to later, and lists are ordered. So that's why they are indexed and we can access different elements using their index. Okay, so let's move on to the next problem. We're given the following list, and we want to change the first item in the list to orange. So can you guys open Google Colab or whatever IDE you're using and um, try to attempt this problem? And if you are finished, feel free to say the answer or share your screen. Okay, so let's first run the first cell. Okay, so in order to change the first item in this list, we will access the first item, which is index 0, and set it to orange, which is what the problem wants us to do. So very important to note that in Python and in most languages, lists are 0 indexed. So we start with index 0. And then now if we print out fruit 0, we should get orange now. Okay, so for the next one, let's try to access and print out the second item in the list. Does anyone have any ideas? It's a little bit quiet today. Okay, so in order to print out the second element, we can do pretty much the same thing we did for the previous one, where instead of 0, it's 1. So now we get banana, which we know is the second element. So now let's add peach to the end of the list. Okay, so Michael said print peach sub 3. So it's not, for this one, it's not really the same thing. First of all, um, if you try to do fruits sub 3, you'll get an error since the list has length of 3 and an index of 3 would be out of bounds. So you'd get an out of range error. So if we want to add a new item that's not there, we can use the append method. Okay, so peach. And then now we can print out fruits, and then we get peach. So the append method basically adds something to the very end of the list. Does anyone have any questions about this? Okay, then let's move on. So for the next question, we want to remove peach. So we just added it. How can we remove it? Okay, so the most simple way to do this perhaps is, oh, okay. So the most simple way is to do fruits dot pop. Um, so this basically removes the last one from the list. So yeah, pop also returns the last item, so that's why it's being printed. But now if we try to print fruits again, we will see that it's not there anymore. Or I think I ran it twice, so it deleted another one. But yeah, let's run everything again. Yeah, so now we only have orange, banana, and cherry. Another way you can do it is to use the remove method. So we can do fruits dot remove peach. And now it's also not there anymore. So this is just a quick review of some of the most common methods we use when we're dealing with lists. So now let's try the next one, which is inserting elements um, in between other elements. Okay, so for this one, since we're inserting or basically we're adding a new element to the list as well, we can use the insert method. And so we want to insert it between banana and cherry. So banana is index 01, and we want the new item, which is watermelon, to be here. So that's index 2. So then we use watermelon here. So now we have inserted it. So I'm not sure if you guys learned about list methods last class, but these methods are basically kind of like tools that we use to perform different actions. And these are only some of the common ones. We can see there's a lot more methods here. For example, append adds something to end. Clear basically clears out the list. Um, Copy, count. So there's a lot more. And another useful one is sort. So if we have like a list of numbers, the sort method will help us sort the numbers from least to greatest or in order. So yeah, we'll talk more about methods and more of these details later when we get into functions and methods. But for now, these are some very useful things that we can do when we're talking about lists. Okay, so the next problem doesn't need to use any methods. It's more straightforward. So let's try to do it. So given an int list, I have provided one here, but you can make it any list you want. Check if the first and last elements of the list are equal. So we also haven't learned about writing our own methods yet. So for now, let's just create our own list. It could be anything you want. And for that list, using logic, not just if you know if they're equal or not, using logic, print out true if the first and last elements are equal and false if they're not equal. Or you can also print out like equal or like not equal, like strings or booleans, however you choose to do it. I hope that made sense. Yeah. Do you guys understand what this is asking? Yeah, so um basically if we're given a list called nums, um we want to print out if the first or last elements of the list are equal. So the first element for this list specifically is 1, and the last element is also 1. So in this case, we would want to print true. So I want you to try to do that. Um, Basically comparing the first and last element by accessing them and then comparing them and then printing, like checking if they're equal, essentially. Okay, so yeah, yeah, you declared a list. Um, so now let's try to check if the first and last elements are equal. So how can we access the first and last elements? Okay, you're very close. So in order to access the first, oh yeah, you're right now. So nums sub 0 will give us the first item, right? Since index 0 is the first item. And so now this part is a bit more tricky. How can we get the last item? So first let's try to just like count and see which index we should be using. And then let's try to find a more generalized way to do it if we don't know the exact length of the list. So in this case, what would be the index of the last element? Okay, yeah, so the the actual value of the last element is 1, but the index is not quite 1. Yeah, 4 is correct. So yeah. nums 4. So how can we check if these two values are equal? What's the operation we use for checking equality in Python? So for a computer, it's not that obvious. So in order to check if two, so basically these two, if we do the type of these two, it's going to give us an integer, right? So how can we check if two integers are equal? So does everyone understand that the type of this, of each of these will give us an integer, that these are ints? Yeah, so Jeremy is correct. So two equal signs checks if these two are equal. So I want to emphasize this one more time, the difference between two equal signs and one equal sign. This is a very common mistake. One equal sign is used for assigning values. Right, so when we're declaring or changing the value of a variable, on the left-hand side, we have the name of the variable, and on the right-hand side of the equal sign is the actual value we want to set to the variable. So in that case, we use only one equal sign. Two equal signs, on the other hand, is for checking equality. Now, to be a little bit more technical here, the type of this whole expression, num sub 0 equal num sub 4, the type of this is a Boolean. So if they are equal, the value is true. If they are not equal, they are false. So we didn't, I just realized we didn't learn about if statements yet, but let's just do, I'm going to talk about it really quickly. So later on, I think maybe even if we finish early, we'll talk about it today, but if statements basically check if the condition inside is true. If it is true, we can print true, right? So in this case, we expect it, um, I mean, okay, we can print true. So you can actually also just print this directly, since I said earlier that this value itself is a Boolean. So if it's true, this will print true. If they're not equal, for instance, this will print false. Okay, so now we know that the index of the last item is 4. What if we have an unknown list? Or what if, so commonly, like, it's best practice that we do not hard code these values. What I mean is, like, hard code is like you give the specific value. We want to tend to make it generalized so that when we change the list later on, we only have to change one value. We only have to change the list itself and not any code later on. So that's what I mean by like hard coding. So what's a general formula for the index of the last element? Yeah, so Qiao is saying we can pop the last element and then append it back later. Yeah, I saw your code. That does work, but it's not the most efficient way to do it. We can actually check if they're equal without changing the list itself. Okay, so there's actually two ways to do this. I'm gonna talk about one of like a more intuitive way and then talk about a more clever way to do it, which only applies to some languages like Python. So how do we get 4 in the first place? So we have to note that since this is 0 indexed, when we look at, for example, the third item, its index is 2. The fourth item, the index is 3. So the index is always one less than like the actual position when we're counting. So since this is a fifth item, the index is 4. So we always subtract 1. So in order to get the length of the list, we can use the length function, so which is len. So this returns the length of it. The length is just how many values or how many elements are in this list. But like I said earlier, we have to subtract 1. So this formula will actually give us 4. So if we make it same again, it will print true. Yes, last index is always length of the list minus 1. Another way we can do it in Python is to use a negative index. So in this case, it will be -1. How negative indices work is that, so 0 is the first item. When we start going into the negative numbers, we actually go back to the end of the list. So trying to visualize this, it would mean index of -1 is this value, index of -2 is this. So we basically start counting backwards. So -1 will always give us the last item of the list as well, just like length of num minus 1 would. So they're the same thing. So this will also give us true. Okay, does that make sense? Any questions? Okay, if not, then let's move on to today's topics. Okay, so here this is mostly review that we just did. And as you can see over here, this is an example where a list has multiple different data types mixed and matched in it. Did we talk about list slicing last time? I'll also just review this since this is sometimes a bit tricky. So list slicing is similar to strings. So when we want to take a portion of the list, if we only care about like a little segment in the list, we can specify a range of indices. So when we want to access one item, we can just get the index of that one item. But if we want to get a range, like 2 or 3 items, then we have to specify a range of indices, which basically means the starting index or and the ending index. Okay, so for example, we declared earlier we have a list called A, and A contains the numbers 1 through 9. Let's say we only want to get the items 7, 8, and 9. We just want to kind of like extract that one portion of the list. So how we can do this using list slicing is, okay, here's kind of the syntax of it. Similar to um, getting one element, we also use square brackets, and we use a colon here. Before the colon, we specify the starting index. And after the colon, we specify the ending index. So, we want 7 to 9, right? So 0, 1, 2, 3, 4, 5, 6. So 7 is index 6. So the starting index is 6. Now, for the ending index here, we said 99, but you might think 99 is out of range of this list, right? We don't have 99 or 100 elements. But if we're doing list slicing, this is okay. It will basically, since 99 is exceeding the length of the list, we'll basically just take all the rest of the items, or like as much as we can go. Now, something important to note here is that the first index is inclusive and the second index is exclusive. So what that means is when we say index 6, the result of the slicing will contain the item at index 6. But the ending index does not get contained. That item isn't contained. It will copy over all the items from the starting index, including the starting index, up to, very important, the up to the ending index, but not including the ending index. I hope that's clear. So Michael asks, what if the first element is the last number? So do you mean like the list has length 1? There's only one element, so the first and last are the same? You can still slice that, but it's not that the slicing won't be true. It's that after we slice it, we will basically have the same thing as the original. It's just the slicing won't, it's not very meaningful on a list of length 1. There's not many times we will want to do that because it's just not useful. It will give us the same thing if that's what you're asking. Yeah, so we can also leave out either the start or the end. So in this case, the end is 4. So we will go 0, 1, 2, 3, 4. So index 4 is 5. So that means we'll go up to 5. So that it will include 4, but stop at 5. So it won't include 5. But when we don't specify a starting index, it will start from 0. So this is the same thing as a 0 to 4. So the 0 is kind of implied here. Same thing for if we don't specify an ending index. It will basically go all the way up to the end. And of course, you can specify nothing. You don't have to have even a starting or ending index at all. You can just do a colon here. This will basically give us the original list as is, since we're taking everything, essentially. Does that make sense? And also, you can also specify the jump. So what that means is we have two colons. If we are in the case where we have two colons, the first one specifies the starting index, the middle one specifies the ending index, but not including it. And the last one is our step or jump, you can call it. So in this case, when we specify the step as 2, that basically means we're taking every other item. So that's why you see we're skipping items over here. We're basically like skip counting by 2. And also note that when we're slicing a list, we're actually creating a new list. So we're not modifying the list in place. It returns a new list. Okay, does anyone have any questions? Yeah, so let's move on then. We already talked about changing one item. And similarly, I won't spend too much time on this, you can change a range of items. This is very similar to list slicing. It's the exact same logic, but instead of taking those values, that range of values, we're just setting it to something else instead. Yeah, so we also talked about append and insert earlier, and also removing items. So you don't have to exactly memorize every single one of these methods, or even know like what their parameters are exactly how they work, but some of the common ones, it's best to know. But if we can't remember sometimes, we can always just look them up. There's plenty of like tutorials online, or like you can read the documentation, and I will explain like how to use these different functions, and what to pass in as parameters. We'll also talk much more about like what parameters are when we discuss methods in that lesson. Yeah, so we also talked about pop. Pop, when we don't pass in an index, it will delete the last item. If we do pass in an index, it will delete the item at that index. And clearing the list sometimes can be an important tool. So the dot clear method will empty the list. So the list will still remain, but it just has no content in it any longer. So here this is talking about looping through a list. This is very useful, but we haven't learned about loops or like for loops yet. So we'll skip this part for now. Okay, so now let's talk about sorting a list. So the sort method will sort the list in order, but this, unlike the slicing, this sorts the list in place. It doesn't create a new list. It doesn't copy it over. So the sorted function will return a sorted copy. So that's the difference between sort and sorted. When we do list dot sort, it will sort it in place. But if we use the sorted function, which is sorted, and then we pass in the list, this will create a new copy. So as you can see, after we perform this operation, it used to be 1, 4, 2, 5, 3. It's now 1, 2, 3, 4, 5. And there are also, so for now, you don't have to know how exactly the sorting works. It may seem very intuitive to a human, like, oh, you're just checking like least to greatest or like greatest to least, like you're just comparing numbers. And that is essentially what a computer does. And there's many, many different sorting algorithms. You can explore those for fun. Some of the most like well-known ones are like bubble sort, quick sort, merge sort. So those are some of the different algorithms that computer scientists have developed like in the past like decades, within the past century. So yeah. Now let's talk about tuples. Does anyone have any questions about sorting, by the way? Okay, then let's talk about tuples. So tuples are very similar to lists. Tuples are another data type, yet again, in Python, used for storing a collection of data. So a tuple is a sequence of items as well. However, the main difference between tuples and lists are that tuples are immutable. So earlier we talked about in the review what mutable and immutable means. I'll just explain that again. Mutable means you can change it, right? That's what like you think of it like mutations. That's like the word mutable. That's what it means. You can change it, which means you can add, delete, or change items. When we say tuples are immutable, that means we cannot add, delete, or change after it is defined. So after we define the tuple, we cannot change it any longer. Now, there are also some syntax differences between tuples and lists. So earlier you saw when we're creating a list, we're using square brackets. For tuples, we're using round parentheses. And other than that, it's pretty much the same, but inside of the parentheses, we also have items separated by a comma. And as you can see here, accessing items is pretty much exactly the same as in lists. We're also using, but in this case, we're using square brackets to access items by their index. So yeah, this is just showing that when we print out the type of it, it's a tuple. And over here, this is just showing that when we create a tuple, sometimes tuples are also used similar to dictionaries, since that's one of the benefits of it being immutable, which is we can't change it. So here, for example, we specify that the Tom tuple is, so it's a person named Tom. We have their gender and also their age. So now we can assign three variables, name, gender, and age, to the tuple. And when we print it out, we can get items that way. So this is like one, so name corresponds to Tom, gender corresponds to male, age corresponds to 20. So this is kind of intuitive. Okay, so moving on over here, this is similar. I won't go into it. So once again, we're assigning variables to the tuple. And indexing works pretty much the exact same way. If we try to access something that's out of bounds, once again, we'll also get an error. And this is the case with both lists and tuples. The index must be an integer. This is kind of obvious. And negative indexing also applies, and so does slicing. So earlier we reviewed slicing in more depth, so I won't go over it again since it's just the exact same thing. So some of the key differences other than immutable lists and immutable tuples is that tuples use less space. Since we can't change them, they're not as dynamic. And you can also use tuple as the key of dictionaries, which we saw earlier when we were assigning variables, many different variables to the tuple. Right, so we can see that um, so this we can skip this part for now. So yeah, earlier we saw like we had name, gender, and age, I believe. So that's one common use case of tuples. So you might think if lists are much more flexible than tuples, why do we even need to use tuples? Tuples are sometimes very important because since they can't be changed, sometimes we don't want things to be changed. For example, like in this database, we're only storing like I don't know what this example is, but earlier it was name, gender, and age. Since we're only storing those three types of things, it makes sense to have a tuple which is length 3, since we're not going to change it. It's always going to store those types of data, those types of information. So tuples are basically like a dictionary without keys to store data, and we'll talk about dictionaries later. A dictionary is essentially a key value pair. Yeah, I'll explain what that means when we talk about dictionaries. Yeah, so that's it for tuples. Does anyone have any questions? Okay, if not, then that's it for lesson 4, lists. So now we'll talk about lesson 5, decision making in Python. So before we talk about the actual decision making, I want to discuss some more important functions, specifically how to get user input. So in most like mobile applications or websites or things like that, those things all require user input. So you always have to, you're the person that's giving it data. You have to type things, you have to input things yourself. But for now, we haven't really seen what that looks like in Python. So if you want to accept a user input, we use the input function. So this is very similar to the print function where we put the string inside of the parentheses. So as you can see, we have name equals input in parentheses, what is your name? So when we take a look at this, let me wait for it to load. When we take a look at this, it will show a box for the user to enter information. So for example, you can type stuff into the box. So this is user input. And when you press enter, it will now print my name is, and then it will get the name from the input. Does this make sense? It's important that also that even if you type in a number into the box, the information is always taken into the program as a string. So if we want to use it as a number later on, we'll have to parse it as an integer. We'll have to convert the data type. So yeah, this is only meaningful if we store the data they input. So that's why we have to set a variable equal to the input. So yeah, what happens if we want them, for example, to enter their age, but we don't want age to be received as a string since we can't really do any useful operations with an age as a string. So how can we convert the string to an integer? Now Python defines many different type conversion functions to directly convert one data type to another, which is very useful in some day-to-day and also competitive programming applications, since in many cases, the data you're working with may not be the correct type. So once again, you can get the type of a data with the type function. But how can we convert types? So over here, I declared num equal to 9, but it's as a string. We can use the int to convert it back to an integer. This essentially redeclares num to an integer format. So when we print out the type of num after we do this operation, we'll now see we got an integer. However, if num contains something that isn't actually an integer, obviously we can't convert this to an integer. We'll have some errors parsing that. So that's why we'll get um, an error here since we have like characters that are not integers or like numbers in base 10. Okay, then now let's talk about code blocks and indentation. So this is a very notable feature of Python. In many other programming languages, we use curly braces to declare hierarchy, but in Python, we use indentation. So indentation makes the code look very pretty, but it's also required for indicating a block of code. This wouldn't be the case for something like Java. Java only looks for the curly braces and it does not care about your indentation. It does not care about different blocks of code. Although we do use those, we do use indentation in Java just for the code to look aesthetic and very readable. If you wanted to, you can technically, if you had like 100 lines of code in Java, you can technically make that one line of code and it will still run. I know that's crazy. But in Python, that's definitely not possible because you have to have indentation. And you can't have like two lines of code written in one line because Python does not have semicolons. So those are some essential, like fundamental, like design philosophies of Python. And also your indentation has to be consistent. Sometimes we use spaces, sometimes we use tabs. I think this is up to you how you want to do it. I personally prefer tabs. Okay. So when we're talking about any kind of decision making, all decisions are made with Booleans, essentially, right? So some of the most common operators we use for integers are two equal signs to check equality. The greater than sign or the less than sign, those also return Booleans since they check if one number is greater or less than another. If it is, then it's true. If it's not, it's false. And also greater than or equal to and less than or equal to. Okay, then even if you are not conscious of it, every day we make hundreds of decisions. I watched a video recently about this. I believe it's more like thousands of decisions every day we make. Yeah, it's kind of crazy if you think about it. But these decisions define what you do in your day. So in programming, when we make decisions, these are known as if statements. And an if statement works the same way a decision is made. You check a condition like, is it raining today? If it is, then let's not go outdoors or let's bring an umbrella. So that's how programs also see decision making. So we check a condition. If it's true, then we perform a task. And if it's not true, we can move on without performing the task. Or sometimes if it's not true, we want to perform an alternate task. So that's called an else statement. All branching statements begin with an if keyword. So this is one of the most well-known kind of statements. So this is a syntax for it. We use the if keyword, and inside of parentheses, we have a condition. The condition is always a Boolean. After that, we have a colon. Then if the condition is true, we run the code inside, and this code inside has to be indented. The indentation tells Python which code is inside. So if I delete the indentation here, then Python will know statement 3 is outside of the if statement, which means statement 3 will run anyways, regardless. But if it's inside, these three statements will only run if the condition is true. Does anyone have any questions? Okay, then let's look at a few examples and then we'll end today's class. So, okay, let's see here. Over here, we have two variables, a equals 20, b equals 15, and we have an if statement. If a is less than or equal to b, then, okay, it says a is greater. I think this is a typo. It should be greater than or equal to. Then it will say a is greater. And it will print the sum of the numbers and the difference of the numbers, right? So this, all the code inside that's indented will only run if a is greater than or equal to b. If a is not greater than or equal to b, for example, these four won't print. So as you can see, it only printed the stuff outside of this statement. The stuff outside this statement will print regardless of the result of the condition. Right, so earlier we talked about checking equality. These are called comparison operators. We'll talk about logical operators next time, but some of the most basic comparison operators I just mentioned earlier in summary is two equal signs for equality, greater than, less than, greater than or equal to, and less than or equal to. Okay, I think we'll stop here for today's lesson. Next time we'll pick up at logical operators, which are and, or, and not. And we'll also talk about else statement and elif statements. Okay, thank you all for coming today. Okay, thank you.